Hello dear students, today we can have a discussion about the electrochemistry 2, the EMF of galvanic cell. As all of you know, a galvanic cell is a device in which chemical energy is converted into electrical energy as the result of an indirect redox reaction occurring in the cell. Here, thermodynamically, the decrease in free energy of the redox reaction is converted to electrical energy, that is mathematically represented as minus delta G is equal to NFE, where NFE is the electrical energy, where N the number of electrons involved in the redox process, F the Faraday, and E is the equilibrium EMF of the cell. Actually, it is an assembly of two electrode conductors and two electrolytic conductors connected internally by means of a salt bridge and externally by means of a metallic wire. Typical example is a Daniel cell consisting of zinc in zinc sulfate and copper in copper sulfate solution. We look into the figure. Here, zinc in zinc sulfate solution is acting as the anode, while copper in copper sulfate solution acting as a cathode. And schematically, it has a representation that will be discussed later in connection with the convention of galvanic cell. Okay. A Daniel cell or a typical galvanic cell consists of two metallic wire or strip dipped in the respective salt solution. Then the solution connected indirectly for ion migration without mixing, to avoid mixing, by introducing an inverted U-tube, that is a salt bridge containing KNO3 and little agar jelly. An ammeter or a voltmeter is introduced in the external circuit to read the current flow. Okay, as I mentioned, a typical example of a galvanic cell is Daniel cell. It consists of zinc rod dipped in zinc sulfate aqueous solution and a copper rod dipped in copper sulfate aqueous solution. A metal in contact with the salt solution is typically called single electrode or reversible electrode or half cell. Once again, I wish to repeat, a metal in contact with its salt solution is typically called a single electrode or reversible electrode or a half electrode. That is, our conventional anode and cathode are the single electrode. Okay, working principle and generation of EMF of a galvanic cell. At first, zinc metal undergo oxidation by liberating electron, and the zinc ion dissolves in the aqueous solution. That is the oxidation. So the first step is the oxidation, which initiates the reaction and is spontaneous depending on the nature of the metal. And second is the electron that get accumulated in the zinc rod pass through the metallic wire, the outer wire, and reaches the copper electrode and then to the solution in the vicinity of the copper electrode and reduce the copper ion into copper, which get deposited on the cathode or copper rod. That is the reduction. As all of you know, that is, reduction is the process of addition of electron, while oxidation is the process of removal of liberation of electron. So the entire reaction can be represented as Zn solid reversibly gives Zn2 plus aqua plus 2 electron with an oxidation half EMF that is equal to plus 0.76 volts. Okay. And copper 2 plus aqua plus 2 electron reversibly gives copper solid with half reduction potential equal to plus 0.34 volt. Adding equation 1 and 2, we have Zn solid plus copper 2 plus giving Zn2 plus aqua plus copper solid with a resultant E0 cell, that is the EMF of the cell, comes to be equal to 1.10 volt. As you look, that is very important. The EMF of a cell is always a positive quantity. Okay. And here 0 stands for the indication that the cell works under standard state. That aspect will be also discussed later. Thus, the cell generated an EMF of 1.10 volt as a result of the redox reaction, which is given by the difference between cathode potential and anode potential, that is E cell is equal to E cathode minus E anode. If EC and ER, that is E cathode and E anode, both are expressed in terms of the reduction potential. Okay, that is single electrode potential is expressed in terms of reduction potential generally. That aspect is also discussed later. Overall, zinc solid giving zinc 2 plus aqua plus 2 electron, that is half oxidation of reaction, and Cu2 plus 2 electron giving Cu solid, that is reduction half reaction, and Zn solid plus copper 2 plus aqua giving Zn2 plus aqua plus copper solid, that is a total cell reaction. Thus, a galvanic cell involves generally two half cell reaction. One is anode reaction and other is cathode reaction. Each such electrode is called single electrode, and the corresponding potential is called reversible single electrode potential. Now, galvanic cell convention. For a metal ion electrode, that is the most conventional single electrode, the convention is as mentioned below. That is, metal electrodes are shown outside. Okay, the metal electrodes are shown outside and metal ion inside, each separated by means of a vertical line. Metal ion inside are separated by double vertical line, which stand for the salt bridge. The double vertical line represents the salt bridge. Always anode is written in the left side and cathode electrode is on the right side. Okay, the general representation is like this. That is M solid vertical line Mn plus aqua of concentration C1, double vertical line Mn plus aqua concentration C2, that is second is of another metal ion, single vertical line M solid. Here left side is anode while the right side is cathode. Example, zinc solid is around 2 plus aqua, double vertical line, copper 2 plus aqua, Cu solid, cadmium vertical line, Cd2 plus aqua C1, double vertical line, Ag plus aqua C2 Ag. The left side is anode and right side cathode. These are different types of combination of single electrode acting as galvanic cell. Okay, thank you very much. The next aspect will be discussed later.